Alright, this is the setup for my binary adder, the 2-bit adder. And what I have done here already is I've put 3 integrated circuits on what we refer to as the breadboard right here. And we should be able to see the part numbers when the camera wants to focus. So here we have a 7432. It's hard to read right now, but that's a circuit containing OR gate. That's a 7408. That's a circuit containing AND gates. And that's a 7404, the circuit containing NOT gates or inverters. And what I've done already is that I've wired. So before we get there, let's take a look at the 7408, which is right here. That's the schematics for it. We see that here's pin 1, pin 2, pin 3. There's a little notch here. That's that little circle that we see here. It indicates the polarity. It says this is pin 1. Pin 1 is on that side. And so that matches exactly this diagram here on the schematics. Pin 1, 2, 3, and we see pin 7 and pin 14 here are not connected to gates, and that's how the circuit gets its electrical power. So I've connected the pin 7 of the 3 circuits with wires here to this row of holes that is eventually connected to what is called ground. That's the minus of the power supply. And the plus of the power supply, plus 5 volt, is connected to the top row of holes, and with wires I've connected that to pin 14 of my 3 chips. So pin 14 is connected with these little wires to this row here, and that's going to correspond to plus 5. So now what I'm going to do is, going back to this diagram here, I'm seeing that one of the gates, the AND gate, which I need for the carry to generate the carry of my 2-bit adder, is connected to pin 1, 2, and 3. So the two inputs are 1 and 2, and the output is 3. 1, 2, 3. If I go back to the schematics for my 2-bit adder, I see that the carry here is generated by an AND gate, and pin 1 and 2 are the 2 inputs, and 3 is the output. So typically on schematics I will number the pins with numbers corresponding to the circuits. So here it says that pin 1 of this AND gate should be connected to one of the 2 bits that I'm going to add. I'm calling them B1 and B2, bit 1, bit 2, and the other input is connected to the other bit, B2, and the output will be the carry. So this is how I'm going to do that. Going back here, and this is the circuit that has the AND in there. I'm going to use these switches to generate B1 and B2. So I have switches that can be activated up or down. So when they're up, they're going to generate a 1. When they're down, they're going to generate a 0. And I can see their value with these little LEDs here, and you'll see I'll connect them together. So first I'm going to connect a wire here. Oops. So this is going to be 1 bit, and I will want to see its value, and I'm going to connect it to an LED, and I'm going to take another wire here that I've prepared and connect another bit to another LED, like so. Alright, so now I have my 2 switches, 2 LEDs. I'm going to power the kit, and right now the 2 switches are off, but if I change them, you see the little LED changing. Same here. So these are my 2 bits. 1, 0. 1, 0. So now what I'm going to do is connect these to pin 1 and pin 2 of the AND gate, which is in here, and the output of that AND gate, which is pin 3, I'm going to connect to a third LED. So let's do that. So connect B1. So I'm checking again what I want to do. Okay, bit 1 is connected to pin 1. So bit 1 is connected to pin 1 of the 08. You cannot read that, but I can read that the part number is 7408, so I know it contains AND gates. I'm going to connect. Oops, this wire is broken. This wire is broken. I need more wires. And now I'm going to connect. Where am I? Right here. Bit 2 to pin 2 of the AND gate. Alright. B1 through this wire goes to pin 1. B2, bit 2 goes through this wire to pin 2. And the diagram says that pin 3 is the output, and that's going to be my carry signal, so I'll connect that to an LED. So I'm going to connect a wire to pin 3. Where is pin 3? Right here, third pin. And the output of this wire, right here, I'm going to connect to an LED there. So it's kind of a twisted wire. It's a little too long, but that's alright. So now this is my very simple circuit for generating the carry for my 2-bit adder. So the power is up. Here I should have really turned it off. I forgot to do that. The power is up, and I see that if I have 0 plus 0, the carry is 0. If I'm adding 1 plus 0, the carry is 0. That makes sense. If I'm adding 0 plus 1, the carry is 0. But if I'm adding 1 plus 1, the carry is 1. 1 plus 1, carry is 1. So what I'm going to do is that I'm going to continue wiring this adder so that it is complete, and we'll come back when it's all added up, all created.